Hello. Today's video deals with antiderivatives. We have up to this point been given a function, and then we would find the derivative of that function. Well, now we want to look at this process backwards. So rather than given an f of x, is what we did before, and then we differentiate that to get f prime of x. We now, given some f of x, we will go capital F of x, where this is the family of antiderivatives of little f of x. In other words, capital F prime of x will equal little f of x. And whereas before we had a singular derivative, now we get a family of antiderivatives. For example, if little f of x is x cubed, then capital F of x would be 1/4 x to the 4th plus c. Because I can put it where c represents a constant, c is any real number. Because if I take the derivative of that, the constant goes away and I get exactly what I started with. This is using what's called the reverse power rule. The reverse power rule says that if f of x is equal to x to the n, where n is not equal to -1, that would mean that the family of antiderivatives, or we usually just say the antiderivative, even though there's an infinite number, it's the family, is equal to 1 over n plus 1, x to the n plus 1 plus c. This being the reciprocal of the new exponent, where the new exponent is one more than the previous exponent. Notice n cannot equal -1 because otherwise we have a problem. Some of your other basic forms, if f of x equals 1 over x, then capital F of x is equal to the natural log absolute value of x plus c. Any of the basic derivative rules for functions that we had before, we can find the antiderivative. If little f of x is equal to sine of x, for example, capital F of x is the negative of cosine of x plus c. Because the derivative of cosine of x is negative sine of x, and so then the negatives would cancel each other out, and we get what we want, etc. There's a list of them. Again, you should know what the reverse of all these derivatives. That's why I said you need to know those derivatives very well, because we literally need to know them forward and backward. So let's look at some basic antiderivatives of these basic functions that we've had. For example, if I have f of x is equal to 6 cube roots of x to the 5th minus 4 over 3 square roots of x to the 7th plus 5 over 7x. At the moment, I cannot take this antiderivative, but if I do algebra just like I did back before I took the derivative and rewrite this, this is 6 x to the 5/3 minus 4/3 x to the -7 halves plus 5/7 times 1 over x. I'll leave it like that. The antiderivative, capital F of x in this case, the number stays. I'm going to use my reverse power rule. I add 1, take the reciprocal, leave the number, add 1, take the reciprocal, multiply out front, In this case, this is not a reverse power rule antiderivative. The antiderivative of 1 over x, remember, is natural log absolute value of x, and put a plus c to get the family of antiderivatives. And so then we can simplify this a little. 2 goes into 8 4 times, 6 3 times. I get 9 fourths, x to the 8 thirds, minus, should be plus here, 8 15ths, x to the negative 5 halves, plus 5 sevenths, natural log absolute value of x, plus c. That is my antiderivative in this case. Another example, which is c, I think, or e, rather, I believe. F of t is equal to 8t to the 4th plus 4 times 8 to the t. And I want my antiderivative. The first part is using the reverse power rule. Add 1, I get t cubed. Reciprocal of 3 is 1/3. The second part of this is not a reverse power. That is an exponential function. And if f of x is equal to b to the x, an exponential function, its antiderivative is 1 over the natural log of b times b to the x plus c. So in this case, again, the 4 stays. I get 1 over the natural log of 8 times 8 to the t plus c. This is the antiderivative of the exponential. And so then I get 8 thirds t cubed plus 4 over the natural log of 8 times 8 to the t plus c. This would be my antiderivative. One more example. Suppose I have g of x is equal to 4 secant of x tangent of x minus 2 secant squared of x plus 3 over 1 plus x squared. Again, I want the antiderivative, which I'm going to label now capital G of x. Think backwards. What derivative had was derivative secant of x tangent of x? The function that had that derivative was secant of x. And so the antiderivative of that is 4 secant of x. The antiderivative of secant squared is tangent of x, because the derivative of tangent of x is secant squared of x. And do you remember what had an antiderivative of 1 over 1 plus x squared? What had a derivative of 1 over 1 plus x squared? That was arctan. And so this is now my antiderivative in this case.